Okay, well, this is another problem using Planck's constant. And so what we need to know here is that the energy of a photon, and really the problem should say photon energy, because light itself doesn't have an energy, it's the energy of a single particle of light. So then we need to use the equation that the energy of a photon is equal to Planck's constant times the frequency. So as we have the energy, we can compute the frequency by dividing both sides of this equation by h. So the frequency is equal to the energy divided by Planck's constant, which is equal to 5 times 10 to the minus 19 joules, divided by Planck's constant, which is 6.63 times 10 to the minus 34 joules times seconds. So let's just check that the units are correct first of all. The joules will cancel one another, and we'll be left with an answer in per second, which is also the unit of hertz. So substituting these into a calculator, so plugging the numbers into our calculator, we find that this corresponds to 7.54 times 10 to the 14 per second, which we can write as hertz. And we could consider that problem to be finished, but we usually like to have nicer units than multiples of 10 to the 14. So let's just remember what we already know, what the SI prefixes are. Kilo is 10 to the 3, mega is 10 to the 6, giga is 10 to the 9, tera is 10 to the 12, and peta is 10 to the 15. Well, a nice way of expressing this number would be in units of 10 to the 12. So we'll remember, therefore, that we can write a terahertz as being equal to 10 to the 12 hertz. And if we divide both sides by 10 to the 12, we see that terahertz divided by 10 to the 12 is equal to hertz. So I can make an algebraic substitution. I'm just going to line that off. So this number, the frequency, is equal to 7.54 times 10 to the 14 times terahertz divided by 10 to the 12, which is equal to 754 terahertz. So that's my preferred form for this answer. And for visible light, just as the normal SI unit for wavelength will be nanometers, so the SI unit for frequency for light in the visible range of the spectrum is usually quoted in terahertz. Anyway, we're done.